we're AeroCure, and we're solving a problem that most people ignore until it becomes dangerous: mold exposure in living spaces. Mold isn't just an inconvenience, it's linked to respiratory issues, allergies, and long term health risks, especially in densely populated environments like dorms and hospitals. So we asked a simple question: what if we could stop mold before it starts?
AeroCure is a low-cost, portable environmental monitoring device that detects when conditions are ideal for mold growth and alerts user before the mold growth becomes visible. We use two sensors. The first one is a DHT11 sensor to measure the ambient humidity and temperature, and we have a thermistor we attach to the wall to measure the surface temperature where mold actually grows. These sensor inputs into the simple algorithm that classifies risk. The device gives instant visual feedback using these also displays that real-time environmental data on LCD screen. This device also includes a built-in wall mount in the back with a sliding back panel, making it easy to install in high-risk areas, as you can see in our design right here.
So current solutions to mold are unsustainable. Mold often causes permanent structural damage to infrastructure, and as a result, people frequently have to tear out sections of walls, flooring, or these approaches produce a lot of material. Our biggest challenge was simplifying our design and prioritizing functionality over complexity. This ultimately made our system more robust and easier to use.
Okay, this is a video demonstrating our product. While stuffy Envision makerspace with limited ventilation, the humidity and the temperature were inside the set range that corresponded to an increased probability of mold growth. When we went outside, the DHT11 and thermistor sensors picked up on a decrease in temperature and a low risk for mold growth, as you can see by the green LEDs. And then in the rec gym, it was extra stuffy, leading to a high risk of mold growth, as seen by the red LED.
So this design is our first prototype. Next, we want to make AeroCure active, not just passive. So first, we plan to integrate a fan module that automatically disrupts friendly conditions. This is done by utilization of a small fan to disturb mold, and that requires far less energy, and it's far less energy intensive than relying on power-hungry HVAC systems that circulate air and keep risk low. I'd like to establish communication between AeroCure and HVAC systems to work together to eliminate risky air with the least amount of energy.
Additionally, we plan to create a machine learning model, for example, like with Impulse AI, to be able to recognize trends for certain mold optimal conditions. Currently, we aren't able to do this due to lack of data set. We were able to find indoor air quality data sets online, but that's not really what we're looking for. And we want specific humidity and temperature conditions for a certain mold growth. We have an online GUI to save and plot data and eventually use it to our own system. Long term, AeroCure could become a smart building ecosystem, both health outcomes and energy efficiency.
AeroCure bridges a gap between environmental sensing and preventative healthcare.
Thank
Thank
you.
you.